This is the story of Air Algérie Flight 5017. Air Algérie is the state airline of Algeria, and we've covered one of their accidents on the channel before. On the 24th of July 2014, an MD-83 was flying from Ouagadougou Airport in Burkina Faso to Houari Bouamende Airport in Algeria. The plane had 116 people on board, with 6 crew members. At 1:02 a.m. local time, ATC cleared the plane to start up. They were planning to depart from runway 22 of the airport. At 1:10 a.m., the crew talked to the ATC about their departure. They asked for flight level 330, but quickly changed their minds and asked for flight level 310, as their plane was too heavy to make it to flight level 330. The controller agreed and gave them a flight level of 310. At 1:15 a.m., the plane finally took off and turned onto a heading of 023 degrees as it climbed to its cruising altitude. The autopilot was turned on as the plane reached 10,500 feet. As the plane climbed, the pilots were transferred to Ouagadougou ATC. The pilots informed ATC that they were turning left to 356 to avoid some bad weather. The crew, now having avoided the worst of the weather, continued their climb to their cruising altitude of 31,000 feet. At 1:37 a.m., the plane had finally reached its cruising altitude, and it was flying at a speed of Mach 0.74, or about 500 knots. Once the plane leveled off, the plane began to speed up by just a little bit. It went from 0.758 to 0.762 Mach, or from 501 to 504 knots. But after this, starting at 1:39 a.m., the plane's speed started to fall. The plane was losing speed, but the engines were generating the same amount of thrust as before. The plane also began to slowly pitch up. Not a good sign when you're losing speed. ATC had been trying to reach Flight 5017, but without success. Another plane offered to relay messages to Flight 5017 in case they were having radio issues, but soon enough, Flight 5017 comes on the frequency and says that they're doing a, quote, avoidance maneuver, end quote. The air traffic controller asked the crew to squawk 3235, but the crew never responded, nor did they change the code. Meanwhile, in the cockpit, things were going from bad to worse. At 1:44 a.m., both engines began acting in weird ways. The EPR and the N1 values began to vary erratically. EPR stands for engine pressure ratio. EPR is the ratio of the turbine discharge pressure divided by the compressor inlet pressure. Basically, the pressure of the air coming into the engine divided by the pressure of the air coming out of the engine. It's a measure of how much thrust an engine is producing. N1 is the speed at which a fan in the engine rotates. The higher the N1 value, the more thrust the engine produces. The EPRs first increased, then decreased. The N1 increased to 91% and then was between 81 and 87%. With these critical parameters fluctuating, the pilots were probably confused. The plane also started to roll over ever so slightly, at about 4 degrees to the left to be specific. As all of this was happening, the plane had lost a lot of speed. At 1:45 a.m., the plane was at 205 knots and the nose was pitched up at 9 degrees. The plane now started to lose altitude and the rolls became more prominent. As if all of this was not enough, the engines were not producing as much power as before. They were almost at idle now. The plane would stall if this kept up. At 1:45 a.m. and 35 seconds, the autopilot disconnected. The plane was in a dangerous attitude. The nose was up by 25 degrees and they were flying at 162 knots. The plane had already lost 1,150 feet of altitude and the engines were at idle. Shortly afterward, the plane's nose started to pitch down and it started to roll to the left. Flight 5017's wings were not generating enough lift to keep the plane in the air. Very quickly, the nose was down by about 80 degrees, and they were in a 140-degree left bank. In other words, they were in a nosedive. Throughout the dive, the elevators pitched up, and the ailerons were trying to counter the roll of the plane. The pilots were fighting tooth and nail to recover their plane. But unfortunately, Their efforts were in vain. Air Algerie Flight 5017 crashed near Gossi in Mali. All 116 people aboard the aircraft unfortunately died. In a disappointment to the investigative team, they found out that the CVR on the plane had malfunctioned. The recorder did not fail, but it kept recording over previous conversations without erasing them first. The FDR, however, did survive. To get an idea for what went wrong on Flight 5017, we need to look at the weather at that time of the year, between May and October, in the skies over Africa. The intertropical front, the area where the warm Saharan winds and the moisture-laden Atlantic winds meet, can be a hotspot for convective activity. This can cause very heavy rains and strong winds. On the day of the flight, the intertropical front had a massive weather system north of Burkina Faso. Moreover, readings taken off the storm on the 23rd and 24th of July show that temperatures in the clouds could have been as low as negative 73 degrees Celsius. It was in this weather that Flight 5017 took off. The takeoff and climb out were normal. Realizing that the crew had engine troubles, they decided to focus on the engine parameters to see if they could spot something out of the ordinary. They did see something. The investigators realized that the crew had not turned on the engine anti-ice system. The engine houses a number of important sensors. For example, the EPR values that we talked about before. It's a ratio of the pressure of air coming in and the exhaust coming out. The sensors that measure things like this are housed in the engine. If those sensors were to get clogged by ice, they could mess with the EPR readings. This in turn would corrupt the data that the pilots saw and the data that was being sent to the autothrottle. The investigators combed through the data to see if the pilots turned the engine anti-ice system on. To their dismay, they realized that the pilots had not turned the engine anti-ice system on for the duration of the flight. Since we don't have the CVR data, we don't know if they just forgot to turn it on or if they were going to do it later on. The temperature outside was colder than what it needed to be for them to turn on the engine anti-ice, but they didn't. The western edge of the storm front had ice crystals in the air, but it did not contain supercooled water. Supercooled water is dangerous for airplanes. The water hits the plane and then freezes. If the water were to freeze on the plane's wing, it would change the wing's shape entirely, greatly affecting its ability to generate lift. But in this case, that didn't happen. The wings were unaffected. Once the plane reached cruise, things seemed okay at first. Their speed was stable and they were cruising at Mach 0.74 at 31,000 feet. Then, after 2 minutes of flight, the plane's speed began to climb ever so slightly, and the second engine's EPR value became erroneous, as the PT2 sensor that was measuring the pressure of the inlet air had clogged up. The autothrottle then did something that made the situation worse. The pilots had set an EPR limit for cruise. This meant that the autopilot could not increase power to a value above the EPR limit. With the blockage sending wrong information to the autothrottle thought the engine was producing more power than the EPR limit and therefore throttled the engine back, when in reality the engine was producing just the right amount of power prior to the power reduction. For the next minute, the gap between the EPR values continued to increase. As this happened, the autopilot switched to Mach ATL mode 3 times. The Mach ATL mode is shown when the requested throttle movement would take the engines above the set EPR limits. So when the pilots saw Mach ATL, they should have realized that the autothrottle is trying to push the engines past the set limits. Moreover, Mach ATL limits the thrust at the EPR limit. The plane was now in a low energy state. Soon afterward, the left engine began to show the same symptoms. The displayed EPR values shot up and the autothrottle pulled back. It too was now clogged. Soon afterward, engine RPMs for both engines started to go down. This may have been the crew manually pulling the throttles back, seeing the high EPR numbers. Figuring out what was wrong was not so straightforward. They were being told that the engines were producing too much power, and there was no clear indication to let the pilots know that this was not the case. Soon after that, the second engine was throttled down, and the plane no longer had the thrust to cruise at Mach 0.74 at 31,000 feet. For the next few minutes, the gap in the EPR values of both engines had decreased, and the N1 values were quite close to their actual values. A quick glance would not reveal anything wrong, but the problem was there. The engines were not delivering enough thrust. The clogged sensors were making it look like the engines were producing enough thrust. As a consequence, the speed of the plane dropped from 278 to 213 knots. The crew, under the workload of navigating the storm, did not notice. The plane started to pitch up. At this point, there were aural warnings indicating the movement of the trimmable horizontal stabilizer, but the pilots did nothing. The autopilot was in altitude hold mode, and to compensate for the loss of speed, the autopilot pitched the nose up in an attempt to maintain altitude. At first, it was imperceptible, but it became more prominent as the plane lost more and more speed. You can see where this is going. The crew radioed that they were on an avoidance maneuver. The ATC never heard from them again. It was obvious that they were near a stall right now. They needed to increase power and descend, but the FDR recorded movements of the throttle. They were doing a checklist for erratic EPR values, which required them to move the throttle and observe changes in the EPR values. But this wasn't all that they had to do. They still had to avert the stall. As the speed fell below 200 knots, the stick shakers kicked in, but the crew still did not disconnect the autopilot as they should have. The autopilot pitched the plane up even more in an attempt to maintain altitude. They were now at 24 degrees of pitch up. Due to the high angle of attack, the engines surged and the thrust dropped to idle. The crew disconnected the autopilot 25 seconds after the stick shakers were triggered. But even after disconnecting the autopilot, they were trying to level the wings. They pulled back on the control column, the opposite of what you should do in a stall. With no visual cues, in the dead of night, they kept pulling back on the column until they hit the ground. But we still don't understand how the crew of an airliner could let this happen. Pilots are told that icing can occur if the outside air is colder than 6 degrees Celsius or 42 degrees Fahrenheit. Crews also turn the anti-icing system on when they see icing form on the corners of the windshield. But in some cases, the engine sensors can get clogged up even if the windshield shows no signs of ice. If the crew were using the windshield to judge the amount of icing on the plane, then they might not have turned the anti-icing system on. Moreover, they thought that the engine sensors could only get clogged up in the climb phase. The procedures also tell the pilots that warm air has more moisture and therefore the risk of icing is higher when the air is relatively warmer. For example, the procedures state that below negative 20 degrees Celsius, icing should be less severe. In the present case, the temperatures were below negative 30 degrees Celsius, under which the water in the atmosphere is essentially present in the form of ice crystals, without the water content necessarily being very high. The operating procedures do inform flight crews that heavy icing has on occasion been reported at temperatures as low as negative 60 degrees Celsius, but this does not inform them of the icing risk to the engines. The airplane also had its fair share of blame in this crash. When the speed first started falling, the plane was under autopilot, and the autopilot had no protections against letting the speed of the plane fall to a really dangerous level in that phase of flight. The crew had to be really attentive to notice a loss in airspeed. In similar cases, the stall warning was the first sign of trouble for most pilots. Data from high-altitude tests showed that there wasn't much of a buffer between the onset of the stick shaker and the actual stall, cutting down the time that pilots had to react to the situation. But the thing that really sealed the fate for Flight 5017 was the autopilot. The autopilot was in the altitude hold mode. Even when the power from the engines was on its way out, the autopilot kept pitching the plane up. The pitch increased as the plane had less and less power to work with. When the stall finally hit, the pilots were probably startled, and it significantly reduced their response time. After factoring in their poor training, which did not emphasize on immediately taking back control, it's easy to see why the crash of Flight 5017 happened. Thank you for watching this episode of Mini Air Crash Investigation. A big thank you to My Lost Airplane fan for letting me use his amazing videos on my video. If you like the videos that I make, do consider liking and subscribing. It really helps the channel grow. I'll catch you guys next time. In the meantime, stay safe and wash your hands.